Assalamu alaikum. My name is Moaz Ahmed and in this video I will be explaining the lab number 4 of microcontrollers and embedded systems. In this lab, we are required to implement C programming on Atmega 328P and interfacing hex keyboard with Atmega 328P using Atmel Studio and Proteus. The main objectives of this lab is to familiarize ourselves with basic input and output controls in C programming and learn to program Arduino using C language and using 7-segment display with Arduino along with hex keyboard for input. So the main task of this lab is to make a simple counter and using 7-segment displays. We will be using the cathode 7-segment display, and then we want to use the 7-segment display with a hex keyboard for our task number 2. And in that task, we will be giving input from the hex keyboard by pressing a button, and that specific number will be displayed on the hex keyboard. So if I go to my code, this is the code for our task number 1, which is simple counter. And here we can see that we have defined the frequency and then delay and input output library. And then we have defined here all of the different schemes for displaying different numbers. Like this one right here is for 0. 0x3f means that in binary it will be something like 0 0 0, sorry, 0b 0 1 0 0 1 1, and the next term will be 1 1 1 1. So if I go back to my lab manual, and here we can see that since we are using the cathode, all of these LEDs are on, and only this LED in the center, the one with Q, will not be on, thus representing 0. In this way, different schemes are implemented here in the character list for representing different numbers. And here we have turned on both port C and B as output. And then we have defined two new numbers as characters, and we have named it num and num1. And then we have sent a word 0x3f and 0x3f, which means 00 to port B and port C. And in the forever loop, we are calling a for loop, and we are starting it from num1 is equal to 0 and num1 is less than 10 for representing numbers on one 7-segment display. We will be using two 7-segment displays, and as long as this loop is continuing, it will enter it, and in it it will set the port B. Port B will be 10's value, and it will set the port B to whatever number here is, and it will call that particular member from the character array that we defined here. Then it will it will provide a delay of 50 milliseconds, and then it will call another for loop for zero's value, and it will keep on iterating it as long as this for loop goes, and after it exits the loop it will move it back to 0 by this line, and it will increase the value of port B by 1. So if I go to my Proteus file, we can see it right here that after each iteration, the number is continuously being increased by 1. As soon as it is past 9, the other 7-segment displays shows 1, and this one is back on track. So this is the 7 segment display and this is task 1. Now if we move to task 2, this is the task 2, and we can see here that first of all we have defined the frequency, delay and input output library. In the main function we have defined the same procedure as earlier, different schemes for number display. Port C and D will be output this time. Then we have two characters, temp R and temp C. And in the while condition, we have defined for DDRB as output, and port B will be 0x01, and then we have stored the input value of temp R is equal to pin B, and pin B's value will be stored in temporary register type, and then we will perform if else conditions on these temp else conditions. So if it is equal to 0x11, this function will be performed, and if this condition is true, then it will set the D port B as higher output, like first 4 bits will be output from D4 to B4 to B7, and B3 to B0 will be input. So this is the code, and in all of these conditions will be tackled for different numbers. So if I go to my protest file and if I run this code and let's say press 1, we can see here that the number 1 is displayed, and if I press 3 we can see the number 3 is being displayed, and if I press 2, so if I press 1, 1 is being displayed. So this is the circuit. If I press, let's say 3, number 3 is being displayed, and similarly all of these numbers will be displayed whenever that key is pressed. So that's it from this lab, and I hope you learned something valuable. Till next time, Allah Hafiz.